Okay, we're back. We're back. I'm going to go over some stuff right now. Hold on. Okay. We're gonna do some SAT questions, bank questions once we go over the um all the units first. I'm still in the middle of doing this one. I'm gonna have. Okay. All right. Let's go. Okay. So the equation models the horizontal. Models the horizontal distance s in centimeters of a particular image on a computer screen from the left-hand edge of the screen. T seconds after appearing. If the image moves in from the left-hand edge of the screen during an on-screen animation, how far to the right does the image travel? Okay. So so equation models the horizontal distance. This is the horizontal distance, s in centimeters, of a particular image on a computer screen from the left-hand edge of the screen. Horizontal distance, left-hand screen, seconds after appearing. During how far to the right does the image travel? So it travels, let's see, 17 centimeters. Nice. Okay, let's take a look at these other values here. This is the time when the image turns around. I think that makes sense. I mean, comes to a certain point and then it goes back to positive. And this value is 5.2 centimeters is the value of s after 2.2 seconds. Not sure why anyone would put that. This is double the correct value of the distance. Yeah, I don't understand. Let's go back and go back to the thingy here. Both quadratic functions and exponential functions can be used to model nonlinear relationships in everyday life, such as the height of a falling object or the population change of a city. Okay. All right. What are the common SAT scenarios? Let's take a look at this.
We're told that Rodrigo watches a helicopter take off from a platform. The height of the helicopter in meters above the ground, t minutes after takeoff, is modeled by, and we see this function right over here. Rodrigo wants to know when the helicopter will land on the ground. So pause this video and see if you can figure that out. All right. Now let's think.
Okay. So this is the height, right? And we want the height from when y is 0, the second y, or no, yeah, no, the second x intercept. Excuse me. Okay, so what we would do is we would solve this. Let's go ahead and solve it real quick. Crap.
So you're making it equal. Modules equals 5. 10 minus 1. Check these like this.
Crap, guys. Hold on. My lead
Now you skip the base.
is crapping on me right now.
How about this?
16y.
Okay. All right. Let's go ahead and model this real quick, or solve this. Let's go ahead and find. Oh my gosh, why is my lead killing itself right now? Okay. Solve it. Okay.
minus 9 equals 7. And then 10 plus 3 equals 7.
Dude, it's actually killing itself. I don't know why.
And then
12 equals 10 minus 2.
2 minus
8. 12 plus 3, 5. 17. you said 3, 5, 12, you said 2.
Okay, I found a common
I'm
factor here.
surprisingly good at math, but I don't like this math.
Universal number. Easier than science and reading and
44.
I thought math would be easy.
writing. It's
Yeah.
harder. Writing and reading.
Negative 180.
Science, pretty easy.
180 divided
Math
by.
would be hard.
Let's try 5.
15, 14, 16,
No, 5 won't work. 4, 3, 10, 18, 24. Close. 12 and 15, 24. That's very close. But it should be 160.
Wait, check here.
10, 16, 26. It's very close as well.
You check this already, right?
20,
You check
24.
this
Okay, it's just getting higher. 9, let's try 9. Let's try 8. 28. 10, 26.
It's probably easy.
No, not return, bro. No.
No, my friend did that.
Okay.
That
Oh, yeah.
no, what like that.
20 and
My friend
8.
did like he did all this.
14.
He did all this. But he
Great.
didn't do this.
But if we were to plug this into Desmos, you guys would,
Okay. Yeah, you
I
can
think,
put it.
will know what
I
it's gonna
think
be
I'm
here.
just gonna.
I can't solve it right now. So we're just gonna put it in Desmos.
Okay, yeah, I think I'm done with working. Dad,
Yeah?
Okay.
talk to you.
10. That's gonna be when it reaches the ground. So T would be 10 minutes.
Daddy.
If- But if we figured out the vertex, we would know how high it went. But then it starts going back down, and in 10 minutes after takeoff, it is back at 0, back on the ground.
Okay, let's see what he did here to get rid of this -3, because I'm clueless.
We're told we want to figure out when does that function equal 0. So I say, and then 0 divides by -3. If we did that, this would become t squared, a little bit. Let's just divide both sides by -3. If we did that, this would become t squared, 24.
Oh, I see. Okay. Okay, that's easy. Height versus time. Quadratic function h for the height of an object at time t looks like a quadratic function in standard form. T is the input variable, usually represents.
You went to the auction?
Yeah, that's what I just did right now. But I was just seeing what he did to do it manually. Yeah, and he did get the same answers here. It was 10 minutes. Okay, T is the input variable. Cool. It usually represents the time in seconds. Describes the initial height of the object or the object's height when t is equal to 0. So I would assume that these are
Dad,
like
you take off your skin?
time height.
Like
kind of thing. Time height question. So let's take a look at this example here. For example, if the height of a projectile in feet is modeled by the function h of t is equal to negative 16t squared plus 144t plus 32, where t is time in seconds, the initial height of the projectile is 32 feet because the constant term is equal to 32, right? Because y-intercept is going to be at 32, where x, or I mean t is equal to 0, right? When t is 0, or in this, or we can also refer to this as x, we would have a intercept of 32 right over here, right? And that's when x is 0. And that makes sense because that's when it starts, right? You can't have negative time. You can't go back in time. Yeah. So let's move on to this one here. A is equal to x times 3x minus 2. The equation above models A, the area of the rectangle with a width of 8x meters. Let's see, represents the length of the rectangle in meters. Okay, so it's going to be length times width, right? Yeah, length times width. So our x is going to represent our length, and according to the model, the length of the rectangle is, let's see here. Oh, 2 meters shorter than 3 times the width. Yes, the width, no, the length of the rectangle is 2 meters longer than 3 times the width. Pretty sure. No? Then it's this one. No, it's not. 3 meters shorter. Why is it 3 meters shorter? Explanation, please. Okay, so since the area of the rectangle is equal to the product of length and width, x is... Wait, width? Huh? Isn't... Wait, what? Oh, with the width of x meter. Oh, well. Sorry, I didn't notice that. Thank you, Rohan. Thank you. Did not notice that. Okay, well, that makes sense now. So, now that we know that, our length, 3x minus 2 represents our length here. And the length of the rectangle, excuse me, is 2 meters shorter than 3 times the width. There we go. Okay, thank you, Rohan. Okay, what are some common SAT scenarios modeled by exponential functions? Let's take a look.
The expression 5 times 2 to the t gives the number of leaves in a plant as a function of the number of weeks since.
Okay, I'm going to go ahead and solve this before he solves it. I want to check. Okay, so it gives the number of leaves in a plant as a function. Okay, so 2, because t is, so it's like, like it's the exponent of, it's attached to the 2, right? So we're going to have, the population is going to double each week. The number of leaves is multiplied by 2. Yeah, 2. It's going to be multiplied by 2 each week.
Planted. Initial value. 2, the number of leaves. 4.
Yeah, there we go. Okay. If you guys are confused, I mean, honestly, I don't think there's much to be confused about. Let's move on. The exponential function p for population looks like the following. P of t is equal to p sub 0 population times rate to the power of time is p0 times rate to the power, I think p0 is the initial, right? Okay, so p0 is our initial value, like our starting value, times our rate to the power of time. Okay. Well, there you go. There you go. Okay. Let's see. Okay. For example, if p of t is equal to 75 times 1.04 to the power of t, describes the population of a village t years after 2010. T represents the number. Okay, yeah, I already know that. Actually, number of years after 10. But what if it's like fractions? Yeah. hold on. There's the one thing I wanted to go over with for myself. Input variable, initial amount of money, compounding interest. Okay, let's do this example. There was one example where it showed where the exponent was a fraction. May get to that point somewhere. Maybe. There we go. Yeah. Okay. So we'll get there soon. We were over.
Is that we still have two more? The 5-way Wi-Fi router?
Okay, we're back. Sorry, let's see. Function above models the population. Okay, so based on the function, what was the village's population in 1996? So in 1996, right, it's going to be our 0 here. So it's going to be 680. 680 is going to be our population here. Okay, and then what percent is the village's population declining each year? Ignore the percent symbol when entering your answer. Okay, so it is declining. It is declining by 6%, right? We're keeping 94% of our original value here. That should be the correct answer here. Okay, let's take a look at this problem.
A ball is shot into the air from the edge of a building 50 feet above the ground. Its initial velocity is 20 feet per second. 20 feet per second. The equation h, and I'm guessing h is for height, is equal to negative 16 t squared plus 20 ball to hit the.
Could be used to model the height of the ball after t seconds. About how long does it take for the ball to hit the ground? Okay, let's do what he did before here. With that other equation here. Okay, so let's see, we can divide 4, I think. Let's see if 50 is divisible by 4. No, it's not divisible by 4. Let's see, let's try a different value. 58? Yes, no, we can no, not 8, not 8. 8 won't work. 8. No. I'm looking at 2 here, guys. So let's try -2, dividing -2 on both sides. Then we're going to be left with 8t plus 10t plus 25. No. 8t minus 10t minus 25 is equal to 0. Okay. Alright, let's try and solve this now. 5 times 8 is 200. And 10, 20. Yeah, we can do 10 and 20. So let's do 8t. Right. It's going to equal -200. So 10 and 20. Yeah, so minus 20t. Holy crap, my pencil is horrid now. So minus 20t plus 10t minus 25 is equal to 0. And then, I forgot 8t squared. There we go. And then let's go ahead and factor this even more. Plus 5, 2t minus 5 is equal to 0. I forgot to factor that one too. It's going to be 4. No, 4. We can factor 4 out. So it's going to be 2t minus 5 plus 5 times 2t minus 5. And then wait a minute. Wait a darn minute, guys. We didn't need to do that. Just use our quadratic formula. Wait, we didn't need to factor it. Sorry, guys. Wait, no. Wait, we could, maybe? Maybe. 4t minus 5. Okay, and then we'll have 4t plus 5. Okay, just to make sure, let me plug this in the quadratic formula. Even though I know this is a waste of time. So negative b plus minus, no, b squared, is it b squared? Negative b plus minus b squared minus 4ac divided by 2a. And then let's plug our values in. We got -10 for negative b plus minus square root of 10 squared minus 4 times 8 times. Hold on. That's the wrong way. I need to cross this out. It's going to be -10 squared. It doesn't matter. It's going to be positive. It's going to be 8 for AC, so 8 times -25. I'm setting up my quadratic equation here, if you guys were wondering what I was doing. And I'm going to have 2 times 8 in the bottom. Okay, I'm going to have 10 plus minus 100. And then we're going to have 4 times 8 times 25. 800. Plus 800 over 16. And then we're just going to take the square root of 900. It's going to be equal to 30. So 10 plus minus 30 over 16. Okay, so our 2 answers would be 2.5. 2.5 seconds. And negative 20 divided by 16 is negative 1.25. So obviously 2.5 will be our answer.
Or another way to think about it is 2.5 seconds. 5 half.
There we go. 2.5 seconds. Nice. He also uses the quadratic equation as well. Or quadratic formula, sorry. Okay, exponential word.
There are 170 deer on a reservation.
Thank you, Dragos. Thank you, Dragos. Thank you, Dragos. I wish I could show you guys my work, but hold on. Let me try something. Let me see if this works. Let's see if I can connect my phone and show the camera. Hold on, guys. Hold on. Let me cook. Let me see if I can do something really cool. iPhone and camera. Oh man, it doesn't work. Doesn't work, guys. It's unfortunate. That's so unfortunate. Okay, let me see if I can find another way of doing this. No, it's fine. We can do that later. Not very necessary. But if you guys do not understand where I got 2.5 from this question, you can go ahead and ask me. Let's see. Yeah, we were on this question here, so let's take a look.
The deer population is increasing at a rate of 30% per year. Write a function that gives the deer population P of t on the reservation t years from now.
Love how he said that so slowly. Okay, so let's go ahead and solve this real quick. Excuse me. Okay, so there are 170 deer. 170 will be our initial value here. So I wish you guys can see this. Let me see if I can put my camera down by any chance. Let me see if it's possible. Hold on. Wait, guys. I think I can have my. Hold on. Crap, how do I do this without showing my camera here? Okay, funny. Wait, totally Sean's iPhone camera. Ooh, that's promising. Hold on. Huh. That's weird. It won't do it. It's okay. Okay, it's okay, guys. Okay, let's go ahead and solve this. There are 170 deer. That's our initial value. Our deer population is increasing at a rate of 30% per year. Okay, And what is P of t on t years from now? So 30% per year, right? It's going to be our is going to be an exponential function. So it's going to be increasing by 1.3 to the power of t. So what I have is P of t is equal to 170 times 1.30 to the power of t. See what he got? There we go. Yeah, same exact thing. Okay, area of a rectangle. Length times width, commonly known. Height versus time. Okay. Wait, you're not expected to know physics of falling objects. Functions that describe the relationship between height and time will be given to you. However, you might be asked to calculate the height of the object at a given time, or calculate the time at which the object is at a given height. For example, the function above models the height h in feet of an object above ground t seconds after being launched straight up in the air. At how many seconds after launch does the object fall back to the ground? Okay. I mean, obviously I know how to do this, but let's go ahead and plug this into Desmos. And squared plus 64t, or h of t. H of t is equal to that. Okay, and then our value would be 4 seconds. 4 seconds. There you go. Yeah, he just factored. Oh well, I didn't even need to do much there. He just factored that out, divided both sides, and then he divided that. First solution is 0. Yeah, first solution is 0, and the second solution is 4. Where did he get t minus 4 though? Hold on, guys. Oh, he divided the. Oh yeah, I see. See what he did. Okay. Let me make sure that that's all the way. Okay, yeah, that is all the way. Okay, another example here. The function above models P, the evolution of Pallet Town, t years after. Let's do P of t is equal to 227 1.03. Okay. To the nearest whole number, what was the net increase? Net increase. T years after. Is net increase is total increase. I'm pretty sure that's what it means. Let's go ahead and look it up real quick. Length of an open material, net, remaining after deduction. Remaining after deduction, okay. Net increase. I like how they italicize that as if we have to do something about it, but I don't think we do. To the nearest one, what was the net increase? Oh, the net increase. Oh, I see. Okay, so our net increase is 30. No, here's whole number. Huh. The net increase. Oh, the net increase from 1996 to 2002. Okay, we're just gonna plug in 0, 1, 2. Okay, it's gonna be 6 years. So let's, yeah. So we already have it here. So I'm just gonna plug it here. Well, no need to do anything else. So 6. All right. Our nearest whole number is gonna be 224. No, 234. 234. Approximately 271. That's cap. Oh, whoa. There. 271. And then because it's the net increase, we have to get P of 0 as well, and then we subtract these two together. So actually we don't even need to do that. We just do subtract P of 0, and then we get 44.04. Or 44. Okay, let's try it. The length of a rectangular plot of land is 3 times its width. The area of the plot is 1.08 miles. To a rectangle, so length times width would be our area. So if we use x to represent the width of the plot in miles, then the length of the plot is, okay, so let's see, 3 times its width. 3 times its width in the area. Okay, so I got 3x squared. That's unusual. Oh yeah, so 3x miles. Is it 3x or x? Yeah, well, it doesn't give us x, so it would make sense if they had an x choice, just a plain x, but they only gave us 3x, so 3x would be our length. Okay, write an equation that gives us the width of the plot when solved. Oh, hello, Bob John. Oh, hello, ADX Reddit. Hello. I see a new viewer and a returning viewer. Interesting. Okay. It gives us the width of the plot when solved. Oh, hello, Johnny. Let's see here. 1.3 times the width, the length of rectangular plot of land. Just what the area. I got a little bit of a different answer. Yeah. I don't know what that was supposed to mean. Is that an I is equal to 3x? Don't understand. Okay, let's do this one. UG put $500 into a savings account that yields 1% interest annually. Okay, the initial amount of money is $500, and after 1 year, the amount of money in the account is... And we just multiply 1.01 to 500. No, not 5, sorry. Yeah, 500, sorry. Okay, so it'll be 505. After 2 years, the same amount of money in the account is... At this point, let's just... No, there's only one more. Or actually, no, let's actually write our function as well. So it's going to be 500 times 1.01 to the power of what? T? T. And then we can do f of t is equal to that. Okay, cool. And then now we can just plug in 2, and then we get $510.05. Then we can copy our equation. Oh, well. There we go. How do I rewrite exponential functions using different time units? This one's probably going to be helpful in the SAT. Let's take a look.
After a special medicine is introduced into a petri dish full of bacteria, the number of bacteria remaining in the dish decreases rapidly. The relationship between the elapsed time t in seconds and the number of bacteria n of t in the petri dish is modeled by the following function. All right. Complete the following sentence about the half-life of the bacteria culture. The number of bacteria is halved every blank seconds. So t is being given to us in seconds. So let's think about this a little bit. Let's think about it. I'll draw a little table here. So if we have, this is t, and is n of t, and I'll start with a straightforward t. At time equals 0, right when we start, this whole thing, if this t is 0, then 1/2 to the 0 over 5.5 power, that's just 1/2 to the 0. That's all going to be 1, and you're just going to be left with 1,000.
Sorry, it keeps doing that. What the heck?
Bacteria in the petri dish. Now, at what point do we get to multiply by 1/2? at what point do we get to say 1,000 times 1/2? Well, in order to say 1,000 times 1/2, the exponent here has to be 1. So at what time is the exponent here going to be 1? Well, the exponent here is going to be 1. This whole exponent is going to be 1 when t is equal to 5.5 seconds. So t is 5.5 seconds. And likewise, we wait another 5.5 seconds. So if we go to 11 seconds, then this is going to be 1,000 times 11 divided by 5.5 is 2. So times 1/2 to the second power. So times 1/2 times 1/2. So every 5.5 seconds, we will essentially have half of the bacteria that we had 5.5 seconds ago. So the number of bacteria is halved every 5.5 seconds. And you see it in the formula or in the function definition right over there, but it's nice to reason it through and to really digest why it makes sense. Let's do a few more of these. The chemical element Einsteinium-253 naturally loses its mass over time. A sample of Einsteinium-253 had an initial mass of 320 grams when we measured it. The relationship between the elapsed time t in days and the mass m of t in grams left in the sample is modeled by the following function. Complete the following sentence about the rate of change in the mass sample. The sample loses 87.5% of its mass every blank days. So this one, instead of saying how much we grew or shrunk by, we're saying a percent change. So if you lose 87.5%, that means that you are left with 12.5%. 12.5%, which is the same thing as that you have, is the same way of saying that you have 0.125% of your mass. So another way of thinking about it is the sample is 0.125 of its mass, of its original mass, or how long does it take for the sample to be 0.125 of its mass? And there we could do a similar idea. You see the 0.125 right over here. And so I could draw a table if you like, although I think you might guess where this is going. But let me draw a little table here. So t and
back. Okay, so T days. So it's gonna be, it loses 87.5% of its mass every 61.4 days. It's pretty. I don't know why he did that, but that was pretty easy. Let's take a look at this one. Okay. Howard started studying how the number of branches in his trees grow over time. The relationship between the elapsed time t in years since Howard started studying the tree and the number of its branches, n of t, is modeled by the following function. Complete the following sentence about the rate of change in the number of branches. Howard's tree gains 4/5 more branches every. Okay, let's take a look here. Four-fifths. Gains 4/5. So in this one, it's saying it gains 80% more branches. Okay, so that's the same thing as 9/5. So we can say that it gains 4/5 more branches every 7.3 years.
More branches every 7.3 years.
Nice. Hello, no. New or no? No. How do we change time units? Okay, yeah. Okay, so to make sure the exponent 1.62 is 1 when m is equal to 12 and 2, and when m is equal to 24, we need to divide new, I see. Okay. When changing the time units in an exponential function, identify the units equivalents used for the question. Example, 1 year is equal to 12 months. If converting the variable from a larger time to a smaller time unit, we need to make the exponent smaller. For example, when converting from years to months, we divide the variable representing the number of months by 12. Okay, let's see. This is probably good use here. Hello, Satoras. Okay, let's take a look. Right over here. Alright, let's actually read the rest. This is SAT prep. This is the digital SAT. Math digital SAT. Pretty sure it says in the stream title as well. Pretty sure. Oh, what section? This is like, I don't know. There you go. Like quadratic and exponential word problems. Almost done, I'm pretty sure. Wait, let's go to here. So many other things I need to do as well. Information. No, this is the writing. Reading and writing. It's so weird how they say reading and writing when you don't have to write in the digital SAT. Or type. Let's see how much I have left. I have three more. Okay, let's see if we can push forward and see if we can finish that today. I already finished this one. We just need to go over this review here. Foundations. Yeah, I can remove that. Oh yeah. I'm pretty sure it was 2021. I looked it up earlier. It was 2021 where they removed the essay portion of the SAT. Anyways, let's take a look. Tip: if converting the variable from larger time unit, smaller to larger, we need to convert from months to years. We multiply the variable representing the number of years by 12. Okay. Verify that two expressions give us the same values when valued using different amounts of time. Example, 1 year and 12 months, 2 years and 24 months, etc. I see. I see. Okay, let's take a look. The equation above models the population P of a bacteria culture after 8 hours of incubation. There are 24 hours in a day. Since a day is longer than an hour. If we want to write the equation that models the population of the bacteria culture after d days, we must multiply the exponent by 24. Which of the following equations models the population of the bacteria culture after d days of incubation? It's going to be this one. This one's just the exact same thing as this, right? Okay, so h of t is equal to negative 4.9 t squared plus 7.7 t plus 0.5. The function above models the height k in meters of a soccer ball above ground t seconds after being kicked by a soccer player. Okay, what does the number 0.5 represent in the function? So I think this is the initial height. Our y-intercept is 0.5 at 0. No, wait. Being kicked. 0.5. I think it's the A here. This H2 represents the height. Yeah, I think it's A. Yeah. Okay, the value of a rare baseball card was $80 the year it released. Pepe estimates that the value of the card increases by 7% each year and uses the expression 8 times x to the power of t to estimate the card t years after its release. What is the value of x in the expression? X is going to be 1.07. Double check. Yeah, it's 1.07. Okay, Janice used the expression 2300 times 1.058 to the power of t to model the amount of money in her investment account after t years. To the nearest whole dollar, how much money is Janice's investment account after 10 years? Ignore the dollar sign when entering your answer. Okay, we're just going to plug this in. In real life, in the SAT, I would do this as well. 10, no, t is 10, right? 10, t years. Okay, so it's going to be ignore and nearest whole dollar. So 4042. There we go. Okay, a gym currently has 5,500. Remove these 5,500 members due to an economic downturn. An analyst predicts that the gym will lose 2.5% of its members each month for the foreseeable future. Which of the following function models P of t, the number of gym members, t months from now? Okay, so initial value is 5,500, and it will lose 2.5%. So it keeps 0.975. Am I correct? 97.5%. Yes, keeps 0.975. And then to the power of t. Okay, so what function? This one right here. Okay, Roy uses the function above to model P. The daily profit in dollars of his taco truck from selling tacos at X dollars each. Based on the model, at which of the following prices would Roy be able to earn the most profit? Interesting. This should be that's an interesting one. Okay, so which daily profit in dollars of his taco truck from selling which following prices would Roy be able to earn the most profit? Daily profit in dollars. Okay, let's go ahead and plug this in. We got 0.6 and 4. Nope. Or we can earn more profit at a different price. 0.6. 0.6 and 4. Huh. Yeah, I only did that because I didn't know what to do, so let's take a look here. Let's see if we can solve this on our own. So what does this represent? able to earn the most profit? The daily profit in dollars. $1? No. According to the model, the daily profit from selling is 90. You really can earn more profit at a different price. Yeah, it's plugging in. P of 3. No, P of 1, 2, 3, 2. It's gonna be 2. That's where it ends it off. Yeah. It's just plugging it in. Should have realized. The equation above models the number of total downloads. D for an app Clara. D, total number of downloads. D for an app Clara created M months after its launch. Of the following, which equation models the number of total downloads? Total downloads in Y years after launch. M is months. So we gotta multiply 12. It's gotta be the exact same equation though, so it's this one. I don't think my brain works. Me neither. Typically appears that's supposed to be guarantee. It's unlikely, but it doesn't mean the chance is zero. So indeed it could show up in the test depending on their mood. So be prepared for it. Okay, let's go solve this. Okay, the function above models height t. What does the number 1.2 represent? 1.2 represents always an initial value. Always. Maybe that's a bit of an overstatement. Maybe it's not, but usually most of the time. Yeah, it's the same as the soccer ball one. So 1.2 represents the initial height. Or wait, let's see what the function represents. The height h in meters of a basketball. Okay, so the initial height in meters of the basketball. So it's gonna be a. Okay, let's do this one. The equation above models the number of subscribers S of an online styling service Q quarter years after the service launches. Based on the model, which of the following statements is true? The number of subscribers increases by 60 each quarter year. That's not true. Yeah, really. These are all linear, so these cannot be true. Increases by. Hello, unclear orange. I would assume you're in college by now. If you're calling me kid. Yeah, I was about to say it increases by 6% each year. So that should be our answer. No, wait. Increases, number of subscribers increases each quarter year, each year. Okay, hello, Pinecone. Each quarter year. I thought it was C. Why is it D?
Number of subscribers plus the number of quarter years times 60. It would look something like this for choice A, which clearly we don't have.
Thank you, AK.
Over here, so we can rule that out. The number of subscribers increases by 60 each year. Well, this would be something like subscribers is equal to 1,000 is happening here. And then the number of subscribers increases by 6% each quarter year. Well, the exponential that would describe that would be our initial number of subscribers times 1.06, not to the Q over 4, that would just be to the Q. So that every time.
Wait. But it's Q over 4. Wait, one Q is 1/4 of a year. What? Oh, this October SAT. I mean, I just whatever highest high whatever. So, oh, I did not mean to add you as moderator. Hold on. Holy crap. Okay. Okay. Just whatever high score I can get, hopefully. But like, why? Q is 1/4. 1Q is 1/4. Each quarter year. Q quarter years after the service launches. I don't understand.
Time we a new quarter year, or every time a quarter goes by, you would increase by 6%. But here, we clearly have Q over 4. So every 4 quarters, we're increasing by 6%. We're told
Bruh. Don't tell me this is a quarter of a quarter. Because that'd be the dumbest thing I've ever heard. 1Q denotes a quarter. So what would 4 over 4 mean? What would 4 over 4 mean? Oh, I get it now. Okay, so it increases 6 once 4 over 4, right? Once Q is equal to 4, right? That's a quarter, right? No, wait, that doesn't make any sense. Wait, 1/4 is 1/4 of a. Wait, this doesn't make any sense, guys. Oh, wait. There's always 4. No, wait. Wait, hold on. I think it's. D4 distributed. Q4 is not 4Q. First Q over 4. We all know that Q is a quarter, right? So 4 times Q over 4. Oh, did it say it was per year? Quarter years. It says Q quarter years. What does quarter years mean, bruh? That's what I'm saying. It's 1/4. So this is per year. But what does quarter year mean? Quarter year is 1/4. So 1Q after the service launches. So each quarter year. It literally says, hello, Samine and Goju. It literally says, yes, I'm taking the October one. It literally says, number of subscribers, Q quarter years. Q quarter years. So whatever quarter years. So 1 quarter, 2 quarter, 3 quarter, 4 quarter. Like what?
1,000, our initial year, and obviously you could simplify this, so it would be 15 times Q. But this is clearly exponential. That would describe that would be our initial number of, not to the Q over 4, that would just be to the Q. So that every time we a new quarter year, or every time a quarter goes by, you would increase by 6%.
Oh, guys, I understand it now. I understand it now. Okay, so starting service each quarter year increases by 6% each quarter year. Right? I mean, this makes sense too because 4 over 4 is 1, which would represent 1 year. But I don't understand. It says each quarter year. I would choose either one of these two. Do you guys understand this? Number of subscribers. Wait. Each quarter year. Oh. Wait, no. I don't understand. There's gotta be something down here. Hello, Vic. Honestly, not that inspirational. I'm just a dumb kid. This Q was a quarter. This is so poorly worded. Quarter year, Q quarter years. What the heck? Guys, I'm gonna put this in the chat. See if you guys can tell me exactly why it's not C. Can I post a certain Q&A? No, I don't want to start a Q&A. I want to post a photo. Why this is D. Why the hell is it D? Each quarter year. No, bro. No, bro. Q quarter years after the service launches. Q quarter years. Excuse me. Q quarter years. Q quarter years. So 1Q would equal 1 quarter. 2Q would equal 3 quarters. 4Q would equal 1 year. Q quarter years. Oh yeah, I understand. It doesn't increase by 6%. So if 1 over 4, so 1Q, I understand it now, guys. So 1, right, if Q was 1, that would represent 1 quarter year, right? But it doesn't increase by 1.06 because it's not 4 over 4, right? So it would only increase by what? 1,000, 1.06 to the power of Q over 4. Or let's do P of Q. And then P of Q. And if P of Q is equal to 1, right? If P of Q is equal to 1, well, can I get a definitive answer, please? Well, anyways, I mean, do you guys get it? Just want to make sure you guys get it. Because 1 quarter year, so if it was 1 quarter year, like what this question says, it would be 1,000 times 1.06 to the power of 1 over 4. But that's not increasing by 1.06. So, okay, let's move on to the next question.
A cable company with a reputation.
Okay, cable company with a reputation for poor customer service is losing subscribers at a rate of approximately 3% per year. The company had 2 million subscribers at the start of 2014. Assume that the company continues to lose subscribers at the same rate and that there are no new subscribers. Which of the following functions? S models the number of subscribers in millions remaining T years after the start of 2014. Okay, so 2 would represent millions, and it loses 3%, so it keeps 97% to the power of T. So our answer is going to be our second option here. I'm looking at our second option. Let me double check. T. Wait, what's the difference between this and this? 2.97 T. Oh yeah, this is not okay. So it's gonna be this one, our second option here. Or yeah, second option.
Equals 0.
There we go. Okay, let's move on. Quadratic graphs. Oh yeah. Okay, we already know what parabolas are. Honestly, I already know what this is. This is very recent stuff. Don't need to go over this. Vertical symmetry. Okay, already know that. Okay, match the features of the graph with their coordinates. Okay, let's just do this for fun. Vertex is going to be 2, 9. Wait, did they already do it for us? Wait, what's the lesser root and the greater root? Hold on. Check. Graph x squared minus 3 in the y plane. Oh, yeah, that's pretty easy. It's just alright. I can yeah. How do I find the lesser root and the greater root? Let's see what it says. Greater root, lesser root. Can you tell me, please? Let's take a look at this video.
In this video, we're going to talk about one of the most common types of curves you will see. Lines will
No, didn't say anything. What is the lesser root? Let's take a look. Let's Google it. Let's Google it. Crap, I have to hurry up. Greater root versus lesser root. The root with the larger value of the two. Match the features of the graph with their coordinates. Oh, the vertex. The vertex is 2, 9, right? The y-intercept is 5, 0. No, it's not. No, that's the x-intercept. Oh, I think I think they mean the intercepts. I think they're talking about the intercepts here. Maybe I'm wrong. 0, 5, vertex 2, 9. Lesser root is this one. Oh yeah, okay, so this is, oh wait, what? What? I'm so confused. Lesser root, greater root. -1, 0, 0, 5. -1, 0, 0. Oh wait, hold on. There we go. Wait, what the freak? Oh, there. Oh, what? 0, 5 is our y-intercept. Our vertex is 2, 9. Our greater root is 5, 0. That's going to be our greater root. Okay, so these are just our x-intercepts. How do I identify features of parabolas from quadratic functions?
25. So this thing hits its minimum value when x is equal to 5 halves. And then what is y, or what is f of x, when x... So x equals 5 halves. That's the same thing as 2.5. So x equals 5 halves. And y is equal to -1/4. So if that is -1, 1/4 would be something like that. So that right over... we can use the root this in different forms depending on what we're trying to understand about this function. I have a function right over here of this function. So let's see, negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is equal to 0. So if we use into the original expression, you'll see it, f of x. If we take this coefficient right over, if we square a negative number, it's just going to be a positive. So it's going to be the same thing as 5 halves squared. 5 squared is 25. 2 squared is 4. So this is going to be plus 25 over 4. Plus 20 squared. Well, if we square a negative number, it's just going to be a positive. So it's going to be the same thing as 5 halves 5 over the square videos. But these two things, you can verify that they are equivalent. So that's that part. And now we just have to simplify 6 minus 25 over 4. So 6 could be rewritten as 24 over 4. 24 over 4 minus 25 over 4 is negative 1/4. So minus 1/4, just like that.
What do you mean, OC Jess? Wait, are you taking it this Saturday as well?
So we've rewritten our original function as f of x is equal
Do you get any of this stuff?
to x minus 5 halves squared minus 1/4. Now, why is this form interesting? Well, one way to think about it is this part is always going to be non-negative. The minimum value of this part in magenta is going to be 0. Why? Because we're squaring this thing. If you're taking something like this, and we're just dealing with real numbers, and you're squaring it, you're not going to be able to get a negative value. At the minimum value, this is going to be 0, and then it obviously could be positive values as well. So if we want to think about when does this thing hit its
Or I think it's too late, bro. To be honest, I think it's too late, bro. Dude, it's way too late. This literally took me 2 weeks just to review, including schoolwork. But if you skip an entire day of school for the next, maybe you can get a decent score, like, or maybe a below average score. But I think you're cooked, bro. People were saying I'm cooked, but I think you're good. I hate to break it to you, bro. No saving any. No one's saving you.
minimum value? Well, it hits its minimum value when you're squaring 0. And when are you squaring 0? Well, you're squaring 0 when x minus 5 halves is equal.
November. Okay. Let's get back to this video here.
To 0, or when x is equal to 5 halves, if you just want to add 5 halves to both sides of that equation. So this thing hits its minimum value when x is equal to 5 halves. And then what is y, or what is f of x, when x is equal kind of as two other points to
Okay, this would be a better way to figure out the vertex of our parabola. Just plug in the middle values of our x-intercepts and in our function. Hold on, I'll get water real quick. Okay, I'm back. Okay. Alright, standard form, factor form, vertex form. What forms do quadratic equations take? Vertex form reveals the vertex of the parabola. You don't really need this, to be honest. Okay. Yeah, we don't really need that, to be honest. No need for this. The zero's the graph. The zeros are just the x-intercepts. Excuse me. The graph of the equation y is equal to 1/2 x squared minus 7 is a parabola that opens upward because the coefficient x squared is positive. Okay, the feature of the graph is located at the point -2, 7. -2, 7. This seems to be a vertex form graph. So this is the vertex. 7 is the minimum here. This is an x squared graph. Okay, is the factored form, and the feature is the zeros. Rewrite quadratic functions to reveal specific features of parabolas. A graph of the quadratic equation is shown in the xy plane above. The vertex of the parabola is located at 1, -4. To show the coordinates of the vertex as constants or coefficients, we should use the vertex form. Well, to be honest, we can just plug in the halves of the factor. We can just find the factored form, and then once we have the factored form, we can literally, if we have this and the factored form, we can have the vertex. We don't even need to convert it to this vertex form. It's kind of stupid. Okay, so the x-intercepts of the parabola are -1 and 3. To show the x-intercepts as constants or coefficients, we should use the factored form. Shifting, yeah, shifting is pretty easy. Shifting and scaling, yeah, I already know how to do that. Pretty easy. Easy. stretch vertically. Right, I need to, there's this thing here where it allowed us to do, what's the next one? Exponential graphs. And then polynomial and other nonlinear graphs. Let's see, there's a format thing, how to stretch and shrink a graph. Here we go. It should be somewhere. Should be a format where no, it's not here. Here we go. This is it. Is that we have a vertical stretch, a shrink, and a horizontal stretch. X values are doubled. Okay, the graph x plus 4 squared plus 3 is shifted up the units. Shifted 4 units. Now 4 units left. Left. To the left and 3 units up. Okay, the graph f of x is a parabola that opens upward and has a vertex located at 2, 1. The graph of y is equal to f of negative x has a vertex located at I mean, YouTube recommends a lot of random things, so that would make sense. There's a vertex located at. So this is a horizontal flip. Brother, how old are you? Okay, so this is a horizontal flip over the... Oh, hell nah, bruh. Are you actually serious? You're 19? Dude, you're better off. You're actually better off just speaking normal English than saying Gen Alpha slang. Like, come on, bro. What's so interesting is that he's also from Gen Z, so, I got a lot of old people. I'm surprised there's, my audience is very old. It's so weird. Very, very old. At least older than me. I'm only like 16. I have like 20-year-olds in here. That's kind of crazy. Why did I word it like that? That sounded a lot weirder than... Or am I making you guys sound weird? I think I am. Okay, so it's gonna be located at, let's see, I think this is a vertical, X flip over the X. Over the X? I can't remember. I think it is over the X. Yes, okay, so it's over the X. It's gonna be -2, I think. -2, 1. Same exact y value, I think. Over the X, let me just make sure. Over the, no, this is over the Y, so, I think it's one of these two. I think it's this one. -1. Yeah. This has inspired me to go study for my class. Yeah. Good. Wow. Hey, what's your major? What's your major? Okay, so negative f of x is a parabola that opens downward. Explain. Did I get that right? Yeah, right? Negative 1. Negative 1, too. Okay, I got that one right. This one's just upward. Right? What the hell? CS? Oh, hell nah, bro. CS, you're absolutely cooked. You're so cooked, bro. You can't get a job without having experience in CS. Like, I'm gonna be honest. I've seen too many people. I've seen too many videos. Really, you can only. I mean, like, we're probably like gonna have to work. We're probably gonna be working at Walmart, bro. Yeah. Software engineer at Walmart. I'm pretty sure they have job offerings there too. So let me look it up. Walmart job. Wait, no. Walmart CS job offers. Might as well just switch to a math major. Yeah. We got some Walmart jobs here. This is some good cybersecurity. Now these yeah, software development right here. This could be the job for you, Ishika. No, I don't want Ishika. Got a bunch of jobs here. You can go over to medical. I mean, the good thing about medical is that you don't have to be creative. You don't have to problem solve. All you have to do is memorize what is what. And, well, software engineering could be part of CS if you want. I consider it it's part of it. Why am I getting distracted? Okay, so f of negative x has a vertex located at. Yeah, that was right. 2, negative 1. 2, negative 1. No. It's flipped over the y. I'm stupid. Okay, so that's flipped over the. Okay, if this is flip over y. This is flip over x. Flip over x. So this is going to be a downward, and then this one's going to be the same y value but different. Same y value. It's going to be 1. There we go. Okay, if the function f of x is equal to x minus 3 squared minus 11 is graphed in the xy plane, what are the coordinates of the vertex? Coordinates of the vertex. Coordinates of the vertex. Isn't it negative 3, negative 11? I don't know. Oh, it's plus 3. It's plus 3. Sorry. There. Yeah, this is so stupid. I hate these functions already. Function f is graphed from the xy plane above. Which of the following could be f? Well, they're all negative, of course, because it's downward facing. We have points negative 1 and point 3 as our x-intercepts. So it's going to be negative 3 and 1. Negative 3, 1. It's going to be this one. Okay, if y is equal to x minus 2 squared plus 6 is graphed in the xy plane, which of the following characteristics of the graph is displayed as a constant or coefficient in the equation? Okay. It's displayed as a constant or coefficient in the equation. Constant or coefficient. It's going to be the x-intercepts, I think. It's the x-intercepts? What are the x-intercepts for this? Is it There's 2, 2 and 0, no? It's only 2, right? There's only one x-intercept. No, there's not even an x-intercept here. It's gonna be the maximum y value of the graph? No, no, it's not this. X coordinate of the vertex. It might be this one. It's either B or C here. X coordinate of the vertex. 2, shift 2. Yeah, I could say this. I could also say that. Constant or coefficient? It's this one. Darn it. This weight is a constant in the standard form of the equation. What the hell is a constant? Oh, transformations. Here we go. Okay, these two I already got down. These two I already got down as well. It's just these right here. So there's also a horizontal stretch they didn't mention here. So if you multiply C with X, that would be horizontal stretch. So it'd be, okay, so outside. Okay, so outside is over X, inside's over Y, outside's vertical stretch, inside's horizontal. Horizontal. Okay, cool. Inside's horizontal, inside's over Y. Yes. Inside's, no. Outside is vertical. Inside is horizontal in Y. Outside is vertical in X.
We're told the
Okay, let's go ahead and solve this. Y is equal to 3x squared minus 12x plus 9 is shown. If the graph crosses the y-axis at the point 0k, what is the value of k? The points 0 and k. What is the value of k? This is going to be either, either one of these 2 points. Let's go ahead and get our factored form here. Let's see. It's going to be a horizontal stretch, I can tell. What the hell? X, I'm looking at, 9 and 1? No, we can factor 3 out of this, so it would be x squared minus 4x plus 3. So it'd be 3 and 1, so 3, the factor 4 would be 3 times x minus 3 times x minus 1. So our coordinates are either 3 or 1, and it's going to be A, this is going to be our only option. What the hell, guys? I'm actually stupid. Wait, crosses... Oh, no, I was solving for the x coordinates. I'm so stupid, guys. Guys, please, por favor, read the question. Don't be like me. Don't be stupid like me. Don't be stupid like me, who doesn't properly read the question when I literally could have just looked at the equation and just see. Oh my gosh, guys. This is horrendous. Ugh. Okay, hopefully we don't make that same mistake here. Okay, which of the following is an equivalent form of the equation of the graph shown in the xy plane? From which of the x-intercepts can be identified as constants in the equation? Okay, what are constants again? I forgot what constants were. What are constants? Oh, okay, so anything that doesn't have a variable next to it. Okay, so our x-intercepts shown as constants. It's gonna be, I think it's this one here. I think it's D. Yeah. Okay, let's do this one. We're almost done. We're gonna move on to geometry. Oh no, this is kind of bad. I don't have enough time for geometry today. And I can only finish it tomorrow, and I also have the English section to do. Holy crap. Okay, if you guys are okay with, like, me streaming at 5 a.m. on Saturday, then maybe we could go over the English section. But that's if I don't finish. Wait, let me see, wait, trolling what? Trolling what? What am I trolling about? What do you think I'm trolling about? Genuinely want to know. Oh wait, it doesn't seem that bad. Wait guys, the English section isn't that bad. Oh, I know. But obviously when I encounter the problem, I'm gonna do it that way. I'm just playing the Desmos for most of the questions, or most of these parabola questions. What are the coordinates of the vertex? It's 3, negative 3, 4. Okay, graphs of y is 1 over 8 x plus 4, showing the x with y. Which of the following characteristics of the graph is displayed as a constant or coefficient? It's going to be our minimum y value. It's going to be a shift actually, but minimum x value. No, it's not the minimum x value. It's going to be, I guess, the x-intercept here. Flaming Obsidian, I'd really like to know what you think I'm trolling about. Because I was never trolling about anything. I don't even know what you're talking about. What are the coordinates of the vertex of the parabola? It's 2, negative 4. Graph y is equal to negative 1/2 x squared plus 2x plus 3 should be equal to the following characteristics of the graph is displayed as a constant. It's going to be our y-intercept. It's going to be displayed as a constant. No variable, no nothing. Let's move on. Hold on, guys. Let me do some water. Oh my gosh, I choked on my water. Excuse me. Okay, exponential functions. Okay, nonlinear, exponential with exponents. Exponents. First time SAT exam. Hopefully it goes well.
This is
We're
from
gonna have to go over the really hard questions like these ones, so you can solve those.
the graph basic exponential functions on Khan Academy. And they ask us graph the following exponential function. And they give us the function, h of x is equal to 27 times.
How much am I expecting? Honestly, I don't care. I don't care how much. I just need to study as much as possible, and then perform as best as I can on the test day. That's all I care about. I don't care what score I get.
1/3 to the x. So our initial value is 27, and 1/3 is our common ratio. It's written in kind of standard exponential form. And they give us this little graphing tool where we can define these 2 points, and we can also define a horizontal asymptote to construct our function. And these 3 things are enough to define to graph an exponential if we know that it is an exponential function. So let's think about it a little bit. So the easiest thing that I could think of is, well, let's think about its initial value. Its initial value is going to be when x equals 0. X equals 0, it's 1/3 to the 0 power, which is just 1. And so you're just left with 27 times 1, or just 27. That's why we call this number here, when you're written it in this form, you call this the initial value. So when x is equal to 0, h of x is equal to 27. And we're graphing y equals h of x. So now let's graph another point. So let's think about it a little bit. When x is equal to 1, what is h of x? Well, it's going to be 1/3 to the first power, which is just 1/3. And so 1/3 times 27 is going to be 9. So when x is 1, h of 1 is 9. And we can verify, well, and now let's think about the asymptote. So what's going to happen here when x becomes really, so when x is 1, h of 1 is 9. And we can verify, well, and now let's just think, and you can verify that this works for more than just the 2 points we thought about. When x is equal to 2, this is telling us that the graph y equals h of x goes through the point 2, 3. So h of 2 should be equal to 3. And you can verify that that is indeed the case. If x is 2, 1/3 squared is 9. Oh, sorry, 1/3 squared is 1/9 times 27 is 3. And we see that right over here. When x is 2, h of 2 is 3. So I feel pretty good about that. Let's do another one of these. So graph the following exponential function. So same logic.
Okay. we don't have much time left, so we need to keep moving. Okay, so the function f of x is equal to 2x plus 1, we can find the value, the y value when x is equal to 1, where you can evaluate f of 1. Okay, so we just plug in values at this point. Just plug in values. End behavior becomes very large, plus 1, approaches infinity, cool. Honestly, we're given Desmos, this doesn't really matter. Yeah, but we're just plugging this into a calculator, right? This is not, we don't need to do much here. Let's do f of x is equal to 2 power x minus 1, and then f of negative 3, f of negative 1, f of 0, f of 2. We don't need this one. So it's 0.5, 0, 3. What the hell? What the hell? Are you sure? 0, negative 1, negative point. Oh, wait. I forgot the negative sign. There you go. How to get reading score up? Honestly, I don't know. I never gone through the reading part. Yeah. Just go to Khan Academy and study, to be honest. Yeah, honestly, that's my best advice. The y-intercept of the graph is located at 0. Y-intercept is located at crap. 0, 1, 2. Y-intercept 0. Okay, so when x is 0, it's gonna be, oh, it's this one. Okay, as x increases, y increases. Right? 2, 4. Yeah, okay. As the value of x decreases, the value of y approaches 0. No, approaches, but never reaches 0. No. Suddenly I did something wrong. No, I think it's negative 1. Yeah, sorry. Negative 1. Crap. Don't tell me you have to.
All right, we are asked to choose the graph of the function. And the function is f of x is equal to 2 times 3 to the x. And we have 3 choices here. So pause this video and see if you can determine which of these 3 graphs actually is the graph of f of x.
Okay, let's take a look. So it's 2 times 3 of x. Honestly, I'm just gonna plug values in. I don't care how to get it, right? Look, he's gonna do random math here, or he's probably just plugging it in, to be honest, but I'm just gonna plug it in. I don't care what he does. I'm just plugging it in. Okay, so let's do 0. 0. It's gonna be 2. So our only choice is this graph right here. It's gonna be this one.
Close to 2/3.
Yeah, it's this one. Right? Does he circle it? Well, I know it's this one. I know it's this one. Do this one for most of the max session. But you have to know what to do with the equation. Like, you have to understand what you're using Desmos for. There's a tutorial here. I'll send it to you. The only math Desmos guide. I'm gonna go over this later tonight. You should watch that. Definitely watch that. Yeah. Anyways, are you taking yours this Saturday as well? The most basic exponential function has a base and an exponent. Let's consider the case where b is a positive real number. Okay. Positive real number. Graph f of x is equal to 1.5x are shown below. b is greater than 1, less than 1, not equal to 0. This one's to k. Okay, it's easy to understand. 1.5x, this is decreasing, this is increasing. How do we shift? I didn't get any score. But I do know how to study, because I've studied for things before. And definitely practice is one method. But if you're wondering, that's a good source if you want to know when to use Desmos. Okay. For f of x is equal to b to the power of x, the value of y approaches infinity on one end and the constant 0 on the other. For f of x is equal to b to the power of x plus d, the value of y approaches infinity on one end and d on the other. For f of x is equal to b to the power of x plus d, the value of y approaches infinity on one end and d on the other. Okay, how do we shift? So adding is what shifts it, I assume. Oh, adding increases the horizontal asymptote. Okay, cool. Subtract, obviously subtracting would be the opposite. Multiplying seems to be the y-intercept. If you're multiplying, it'll be our y-intercept. Okay, that's easy to understand. Okay, so let's consider the exponential function f above. The y-intercept is the graph, and the initial value of the function is 64. Because the base of the exponent 0.25 is less than 1, the slope of the graph is negative. As the value of x increases by 1, the value of y is multiplied by 0.25. Which of the following graph is the graph of the function y is equal to 0.5 to the power of x? Excuse me. Graph. So we're gonna have a y-intercept of 4. So it's going to be this one or this one, and this seems to be a decreasing exponential, so it's going to be that one. The graph of the function f is shown in the xy plane above. Which of the following is the graph of f of x plus 2? So it's going to be a increase in the horizontal asymptote. So it's going to be never touching 2, and it's going to be increasing. Yeah, it's going to be increasing, and yeah, it's going to be this one. Okay, things to remember. No need. We already know everything. Honestly, reading that makes my brain hurt.
We're told.
Let's go ahead and solve this. The graph of the exponential function f is shown below. Which of the following could be f? So our intercept is 8 here, and we're going to look for something that's multiplied to 8. So we're going to look at these 3 options here, right? And it seems to be decreasing. So we also have a decreasing here. All these 3 are decreasing, except for this one. This one's not decreasing. This one's above 1. We're going to ignore that one. So it's going to be either B or C. But first, let's go ahead and plug 1 in. So if 1 was equal to, let's try for C here. If x was equal to 1, then f of x would be equal to 6. So f of x, or f of 1, is going to equal to 6. So it's going to be C is going to be our answer here. So that's going to be, yeah. Okay. Let's see here.
We're told the function f is
The function f is defined by the equation above. Which of the following is the graph of y is equal to negative f of x in the xy plane? So we're just pretty much switching all the values inside of this. Is this a harder example? It's not even that hard. We're just switching all the values inside of this we're just multiplying -1 to both of these values. So I'll show you guys too. Or not that, sorry. I don't want to open that. Canva. Show you guys real quick. Okay. Let's do 0. Okay, let's go ahead and zoom in. It's a little bit too much. Okay, so f of x, no, sorry, f of negative f of x is going to equal negative 1/3 the power of x plus 1. Right, so we're going to have a asymptote that, am I right? Might be wrong. Hold on. Negative f of x. So negative f of x. Negative 1 plus. Yeah, I'm pretty sure this is right. Do not understand. Which of the following graph is negative f of x? This is essentially what it's doing, though. Essentially, I'm pretty sure. Pretty sure. Is this 1? No, this is 1. Negative f of x plus 1. Pretty sure that's right. So if this was 0, it'd be 1. Negative 1 would be 0. Oh, so if 0, if this x was 0, then it'd be 0. So it could be any one of these, right? Then we have a, let's see, PEMDAS. So whatever this value is, it's always going to be negative, I would assume. Now let's take negative 1 for example. If negative 1, or negative 1, no, let's take 1. Let's take 1. 1/3 plus 1. Negative 1/3 plus 1 would be positive. Negative 1/3. Negative 1/3 plus 1 would be positive. It'd be positive for just a little bit. Oh, I think it's A here. I think it's actually A. Yeah, it's A. Oh, I forgot. Oh, crap. That took a little bit too long. Forgot that. Just increasing the vertical asymptote, or horizontal asymptote by 1. So, yeah.
Larger.
There we go. Cool. Let's do this practice. Okay, we're almost done. We're almost done. We can finally move on to geometry and hopefully finish that up. Or I can finish that up tonight. Okay, so the graph of y is equal to 32 times 1/2 to the power of x is shown. Based on the equation the graph, which of the following statements is true? As x increases by 1. Okay. Okay, so this is our x-intercept. Our x-intercept here. Increases by... It decreases for sure. It decreases by 1/2. So I could say this one or this one. This one or this one. 16 plus... What?
You throw on my music?
Okay, it does not half. So it's gonna be this one. What the hell? Wait, it halves? Oh, it decreases by 0.5. Oh, literally 0.5. Oh, wow. Well, by a fact, it should have said by a factor. If it said by a factor of 0.5, then that would have made sense. Let's restart. That was crappy. Okay, which of the following statements is about the graph is true? Let's see here. As x increases, y decreases at an increasing rate. see. Okay, restart. Graph of y is equal to 1/2 times 2. So this is our intercept. Which of the following statements is true? As x increases by 1, y doubles. Okay, the graph of y is equal to -3 times 2 to the power of x is shown in the xy plane. Which of the following characteristics of the graph is displayed as a constant or coefficient in the equation? So constant or coefficient is going to be -3, so we are y-intercept. Okay, what is the initial value? It was sort of mixed, I would say. Sort of mixed. So, let's see. Let's actually calculate that right now. We have. Oh, nice. We're almost at the 300 subscriber mark. Very nice. Okay, so I studied for about 5.5 hours yesterday. This one was 3 hours. It's 5.5, 3 hours. Got plenty of other streams. So I'm gonna grab my calculator. I'm gonna assume that all of these are used efficiently. So, all of this was, or most of this was Khan Academy. Now I started Khan Academy at a certain point. It wasn't. Right. What did he do? Yes, I'm taking it this Saturday. Hold on. All hope is not lost. All hope is not lost. Again, values here. Okay, so starting from here. So 3 hours, 5.5, 3.5 plus 5.5. I would say about 10 hours to get to this point. So if you use your time, if you literally just skip school tomorrow and just study for the SAT, maybe you'll probably be able to get through this. If you're familiar with the content, of course, but if you don't understand, then you're actually cooked. But you have to be somewhat familiar. But I mean, we all learn at different paces. Some people understand things faster. I mean, you can't base my stats off of for you know. So I'm just trying to. Anyways, I don't have much time. I'm gonna have to go to bed in about very soon. Okay, so what is the initial value of the function? The initial value of the function. Okay, let's see. I think it's gonna be 3. It's gonna be our y-intercept. Pretty sure. Yeah. Okay, so for the SAT, in order to get a high score, they have these really. Oh, you have to work from 11 to 3. Okay, yeah, but like there's really like tricky questions. There's really tricky questions. There's one that I was gonna go over from this guy right here. There's a lot of things. There's this video. This one. There's a lot of useful things here. There's a lot of useful things. Learning about the discriminant. Learning about let's see. Like it's really just how to like approach problems is what's the main purpose of this video is for. And if you understand all of the basic concepts and learn how to tackle these difficult problems, and then you should be fine. You should be fine. If you're not aiming for a super high score, then yeah, you should be fine. But let's see. Don't need that anymore. You can use this question bank, the supply question bank. I'm gonna have to take a couple of the practice ones tomorrow because my thing is literally on Saturday, so I have to absolutely maximize my time. Yeah, I'm trying to get a 1400 plus. I'm 1400 plus at least. 1400 plus at least. I am. 1500 would be nice. That'd be cool if I got a 1500, but probably not. Probably not gonna happen. Yeah. But Ollie, I would also recommend you, if you don't have any extracurriculars in the morning, please, Ollie, if you don't have any extracurriculars in the morning, please, absolutely, please sleep early. Sleep early. Like literally, like it's the easiest thing. Like just sleep early. Like if you're tense, right? If you're tense and you sleep early, you save time. You save that like the time to actually try and sleep, you know? And you can also wake up early. That's the plus as well. And you can study more. Like I see so many people in my school, they just sleep late because they don't care, right? They just don't care. They don't prioritize anything. But if you really want to do if you really want it, you got to do it, right? So that's what my recommendation would be. Anyways, to continue this, the graph of y is equal to 8 times 0.5 to the power of x over 3 is shown in the xy plane. Which of the following characteristics of the graph is displayed as a constant or coefficient in the equation? 1400 on this one. Yeah, 1250 is trash, but I have grinding reading, which is my bad part. Schedule will probably be 8 through 11. Do a practice test 11 through 3. Okay, Ollie. In order to, are you familiar with all the cons? Yeah, I know. It's the Wiener-Cept. I was just too busy talking. One more, guys, and then we can move on to geometry. Oh my gosh. Oh wait, I gotta read this over. Oh crap. I hate these graphs. Where did you initially prepare for the test? I initially prepared for the test on Bluebook. Like I started doing practice tests, but my fellow viewers actually recommended me Khan Academy, which I think is a good source now that I think about it. And they told me to do the SAT practice test on Bluebook as a time test. You know, once you're comfortable with all the concepts, do the Bluebook tests. Is what my viewers recommended me, which I'm gonna do. My schedule would probably be 8 through 11, do a practice at 11, 3 work, and 3 to 11 is work. 3 through 10. Yes, 7 hours. You gotta make it pretty quick. I would recommend actually. I would recommend. If you're gonna skip school, are you assuming that you're in the same time test? For Ollie. Yeah, that's kind of crazy though. Go away, please. Go away, bro. I have 3 minutes of study time left. Okay, so. Ollie, assuming you're in the same time zone, if you sleep right now, you can wake up at 6 a.m. in the morning, and you can say that you can study between 6 a.m. through 8 or I don't know any of the words. That's true. I mean, most of the words, like sometimes the answer is literally just some random complex word that like literally no one uses, which is so weird. It's like, I don't know why the SAT does that. Oh, dude, Ollie, bro, come on. You gotta stop that. You gotta stop that, bro. You cannot, you can't do that. Like, tomorrow, what I want you to do, I want you to sleep early. Get off, even though I shouldn't be saying this, but, get off. Get off of YouTube and sleep right now. The later you stay up, the worse it's gonna get, right? Ollie is driving. Wow. Yeah, you guys should not be doing this. I do not recommend this at all. Sleep late, wake up early. That's even worse. That's like the worst advice I've ever seen. Ever heard, sorry. The worst advice I've ever heard. Even I have limits, right? That's why, if you set this limit, then you can force yourself to study even earlier, right? Ollie, I want you to sleep early tomorrow. That's please, just sleep early tomorrow. Just try it. Just sleep incredibly early, right? So, if you wake up at, I would assume you would wake up late tomorrow at least, probably 7:30, depending on where you work. and then 2 through 11, and then through 11, you can, wait, no. Schedule 8 through 11. Oh, wait, no, you wake up at 11. You wake up at 8, and then work at 11 to 3, and then 3 through 10. Okay, yeah. Okay, got it. Okay, so, or you could ask your employer to for a day off if you can, just one day off, if that's possible. But I would assume not, but thank you, Javit. Taking this Saturday, yeah. Hopefully I can get through all of these units in time. The good thing is that all these units are actually the same thing, but just harder problems, right? So should be a breeze. Yeah, it's a small business and not much people go to work. You could tell them your situation. And that it's a really, really important test. And maybe they can let you off for just one day. Just tell them it's just for one day, right? You make sure you to add on your application Randbeer Studies. I need to start adding my extracurriculars, to be honest. But please do not sleep late. It's the worst.
Why are you charging your stuff at my station?
Because that's where I charge my stuff. Okay, I gotta go soon, guys. But I don't recommend sleeping late. Can you have my AirPods, please?
Very term.
Please. Thank you.
Does this work?
No, not really.
I thought Kevin said he could fix it.
Really can't.
And stop taking the case out of the phone.
Dude, the case smells really bad.
And I wonder why. It's because of those hands of yours.
Excuse me. Okay, let's take a look at Charlie's extracurricular list, and then I'm gonna go head to bed. Consistent sleep schedule is key, guys. Also remember. No, you're actually not cooked. Wait. 670 on the practice tests, right? Loops by soup. Just gonna. Oh, I took a mock SAT. First Lego League Startup Lead created and enacted introductory pathway to robotics at local middle school for 1,100 students motivated. That's the first one. Okay, that's cool. Plan designed to develop devices to fix real-world problems. The K-12 Inventor Challenge led by Georgia Tech. Charlie. That's nice. I have one thing to say to you. After you list your things. The collector gathered data on turbidity levels of water at Sapelo Island with the Georgia Tech professor to learn the effects of climate on the environment. Okay. I'm gonna harm my own stream. Electrical vehicle rally, manufacturer design built ecologically friendly vehicles, focus on sustainability, how to weld and build structures of small cars. Okay. Developing leadership and engineering skills to participate in engineering competitions. One Georgia State finalist for cybersecurity. Business co-team lead robotics. Planning outreach events from our robotics team. Help us participate in our community. Thank you, Jacob. Thank you, Jacob. I hope your score was great.
cái này là của mình chứ. Tức thì thầm.
Charlie, is that all? Is that all? I have a couple questions. Might as well say it in here too, in the chat to make it a little bit faster.
Nhưng mà đâu có nói mình đi làm da nhưng mà mua đâu. Thì
Okay, so I have one thing to say to you. One thing to say to you. Or actually, oh, hold on. One more question. Yo. Georgia Tech. I'm pretty sure I got a couple emails from Georgia Tech. Hello, Luke McKinley. But Charlie, yeah, I think you have a good chance at making it. Honestly, I don't think it's that hard of a. Yeah, I don't think it's that hard to get to Georgia Tech. But, yeah, but if they were relatively hard, then that would make sense. Your SAT might be compromised a little bit. Mechanical engineering. That's nice, that's nice. My brother goes, so who knows? Most likely, you'll be accepted. Should be fine.
Giỏ đâu ngoài. Này, đem vô phòng cái đi.
Where? In the bathroom? In the bathroom?
Yeah. Not bathroom, the dressing room.
What? The dressing room?
I think you have. I think your extracurriculars are fine. I think you just need to focus on maybe focus a little bit on the these things a little bit. State which boosts your chances even more. Yeah, that's true. You're in state too. That's. But yeah, that's a lot of extracurriculars. Which I don't, of course. I don't have much extracurriculars. I need to start doing extracurriculars. I need to, before I start doing that stuff, I need to, yeah. 16 APs. 16 APs. 16. 16? Did I hear that right? 16? That's a whole lot of APs, bro. That's actually crazy. Actually crazy. Hold on. Let me see how much I'm taking. I was taking, at least I'm planning to take. I've taken a total of 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 APs, and then I've only taken a total of 7 from freshman to junior year. It's not a lot. 4 classes a semester. Oh my gosh, man, dude. Hold on. Let me actually check. I need to make sure that I'm right. I do have to go to sleep. I should not be doing this. Okay, so I'm taking a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 is 8 APs. Okay, I've taken a total of 8 APs so far. But guys, I'm gonna assume it's very humbling. It's very humbling to see people that are better than me, you know? But yeah, I mean, it's more motivation, I guess. But I gotta go to sleep, guys. I have to end the stream. Gotta end the stream. Thank you guys for watching. Maybe tomorrow. Yes, I have to log in. Yeah, I'm gonna take it a little bit easy tonight. Yeah, I do hope you guys enjoyed. Make sure to go to sleep early, please. Go to sleep early. Yeah, I do wish all of you the best, and thank you guys for watching. Hope you guys enjoyed. See you guys tomorrow. Peace.